But our statistics unit is going to be a short unit. Some of it you've seen before, some of it's going to be brand new, okay? So you guys have your own unit on statistics. Put your phones away, okay? So I printed everything ahead of time for you, and you're just going to kind of highlight some important things that you see that are important as you go along. So this packet that I produced for you here is kind of a combination of notes and problems, okay? We're going to start today by talking about measures of center. These are measures of center. I'm not going to circle mode because I don't think mode is a measure of center. It's something else. It's a measure of shape. But center means where is the center of the data, okay? And the two things, yeah, I would highlight it and write the word center, okay? You kind of just follow along with what I'm doing here, okay? Now, we all know what a median and a mean is because you guys have done that back, gosh, probably since what, elementary school? Tell me what the difference between the two. They're both measures of center, but what's one versus the other? Christian? Which one is the average? The mean is the average. Okay, I agree. And the median is the middle. The exact middle, and that's exactly right. Okay? But you didn't. That's good. I didn't though, right? All right, so the mean is the average. And you find the mean, and I've kind of written it in words there, how you do it, and I've written a formula, okay? There are two different formulas for a sample mean and a population mean. We're going to be dealing with populations, okay? And it's just a little thing in statistics that if you ever get to AP stats for any reason, we do samples, not populations. But for our purposes, we're really only going to ever worry about a population, okay? So what this means, at this notation, that what does that sigma mean? We know what that means now. What do we do when you see a sigma? It means a summation. It means you're adding things together. So all this means is I'm going to add up all my values and divide by however many there are. And that's how you find an average. You add them up and divide by however many values. So this just means the sum. And this means number of values. So if I wanted to find the average score on that practice SOL, I could add them all up and divide by however many there are of us in class today. Okay? And that would be the average score. Okay, that makes sense. Pretty easy. Well, it's already written for you, right? And on there. You're just kind of highlighting important parts to it. Underneath the mean box, we now are talking about the second measure of center called the median. And Christian's already told us the median is the middle number. So if you have your highlighter, we know that the median is the middle. The big important part before we can find the middle, and people sometimes tend to forget this, is you got to put them in order. Very good. That is extremely important. From smallest to largest, they have to go in order first. And I'm going to show you on your calculator, it will do it for you. It'll sort the values automatically. So if you have a big list, or you don't want to take the time to sort them yourself, the calculator will do it. So the mode of the data set is what we say is something that occurs most often. Okay? We can say that if there is no number that occurs most often, it has no mode. If there's more than one, like let's say there's two numbers that occur most often. What's the word that's referred to if two numbers occur most often? Bimodal. Good. Okay, so we'll look and see. And if there's several, we call that multimodal. But I typically call mode not a measure of center, but a measure of shape. Because if it occurs most often in the shape, it's going to be a peak of the graph. So if you look over here on this graph I have on the wall, so Trent, look over here, Moody, look over here, Tim. On this graph over here, okay, these are the NFL players, right? Would you call this multimodal, bimodal, or unimodal? Where are the peaks in the graph? There's a peak right here, would you agree? And there's another peak right here. So I have two peaks, so what would that be? Bimodal, two modes, okay? If you look at the one over behind Eric's head, I have a couple of peaks, but really there's only one main peak, would you agree? So that we would call unimodal. It's just one mode.
That's incorrect.
It actually is correct because every team has 52 players, and on a roster of 52, there are very few players that make a lot of money. Most are bench warmers, and most make the minimum salary. So that is actually a true reflection of the graph.
So is that a lot?
If you are a bench warmer, you're making $250,000. It's not nothing to sneeze at. That's a year. That's nothing to sneeze at. Back in 2009.
Is that like more than teachers?
Oh, yeah, just a little. All right, so let's look at this data set that you have at the bottom of your page. Okay? I want us to find all of these values. And I'm going to show you how to do it on your calculator. So go ahead and get your calculator, and let's open it up like I have here. And we are going to go ahead and enter our values in the Stat Edit feature. So if you go to Stat, and you go to Edit, if you have anything in there, so Shamar, you should be on your calculator at this point. If you have anything in there, clear it out. So you want blank, we're only going to use L1. We just have this one set of numbers. And let's go ahead and enter all of these values into our calculator. As you're entering them, tell me something you notice about the data set. So just go ahead and enter them in. Kristen, you should enter yours in. I noticed that too. This one, they're already in order, okay? Which is fine. I'm going to show you a couple of things to do with the order in case it's not already in order, because a lot of times it's not. If I go to Stat, do you see the sort A and sort D on your as an option there? Sort A means sort in ascending order. Right now it is already in ascending order. Ascending means it's going from smallest to largest. Sort D would be to sort in descending order. I'm not really sure why we would need to do that, but we would go ahead and let's double check that we're sorting. We have to tell the calculator what list we want it to sort. So it comes up with a parenthesis and it's saying, what do you want me to sort? Well, where do we put the values? L1. So do you know where L1 is as an option? Second one. So if we go ahead and do that and we hit enter, it'll say done. It means that it went ahead and made sure that list 1 was sorted in ascending order. So if I look now, they're no different because they were already, as Christian pointed out, already in ascending order, which is great.
How did you
I went to Stat.
how did you get the L1?
It's second one. So again, if I just went to Stat, to sort, we have to tell the calculator L1, and then you just hit enter. And if you go back to Stat Edit, they will be in ascending order. So if I want, so that you always want to make sure if you're trying to find a median that you've done that. Okay, and so we're trying to find the mean, median, and we'll do the mode. Now the calculator does something and it will do it for you automatically. If you go to Stat Calc, okay, Stat Calc, and I would write these, if I were you, I'd be writing this down. So if I went to Stat Edit and put the numbers in, and then I went to Stat Sort Ascending into list 1, and now I'm going to go to Stat Calc. I'm going to calculate one variable statistics, which is the first option, 1 bar stats, and you hit enter. It's going to ask you or prompt you what list did you need these statistics done on. I believe the default is L1, which is where we put our information, right? So we're good. We're not going to worry about the frequency list. That's something else. and we'll calculate. And it comes up with a lot of numbers. Okay? Okay? So stat calc, one var stats, is going to create a whole bunch of information here. And we're going to pull out the information that we need. If you go ahead and turn to the next, I think it's the next page, it has these directions on there for you. And it tells you what numbers you need. Okay? One var stats. I think the printout's different, though, because they have 24.1. Did you guys get 23.8 as yours? This is L1. Okay? So that printout's a little is incorrect. Our mean, by the way, is that first number. If you didn't get the same numbers I did, it's probably because you entered the list in wrong. So just double check your list. Go back to stat edit.
No, I didn't. I did that.
You got exactly the same numbers I got?
I don't have to get there. I was
Stat calc, one var stats. I wrote it right here at the bottom. One var stats, and just press enter. List 1, press enter. The first number you see is the mean. Okay, so the mean is 23.8. Good. Now I'm looking for the median as well, but I don't see it here. But it's there. You just have to hit the down button. If you hit the down button, a bunch more information shows up.
What's that line over there?
That means X bar. That just means the mean. That's the notation for mean. The median is 23. The calculator with this command does not give us the mode, however. Okay? The mode is something you'll have to do on your own. So you'll just look and see what numbers do appear the most. Well, it looks like 20 and 32. So what kind of modes do we have? Bimodal. Good. It's bimodal. Good. Okay? So far, from this one variable statistics, the only information that we need and the only information that we've pulled out is the measures of center, which are median and mean. Now, if you look at this computer or this calculator screen, there's some other curious information that you learned back in Algebra 1. What is Q1, Q3? Anybody remember what those are? First quartile, second quartile, third quartile. What are quartiles? Well, let's take this set of data. I'm going to erase the modes just so I can use my information. It's already put in order. The median was 23, so we're going to circle it. If the calculator didn't give me the median, could I count to find the middle? Right? Once it's in order, I can count, and I can see that 1, 2, 3, 4, 5, 6, 7 are on the left, and 1, 2, 3, 4, 5, 6, 7 numbers are on the right. It is the exact middle. The quartile 1, in this case, is going to be 19. Why? Because it's the middle of the left-hand side, right? The middle of the first 50%. What's the quartile 3 going to be? It's going to be the middle of the second half, and so what's that going to be? 30? So the quartiles are just the middle of the two sets of numbers once you've found the median. The median divides it in half. You look at the lower half and find the middle. That's quartile 1. And you look at the middle of the upper half, and that's quartile 3. What kind of graph? Oh, question? Yeah.
Is that based off of how many numbers are up there or the value of those numbers?
How many? Just simply the middle of the middle. So it's the position. Okay? Now, what do I use the quartiles to create? Do you remember from Algebra 1? A box and whisker plot. Go ahead, Travis. Exactly right. So if I wanted to create a box and whisker plot from this, I'm going to use the quartiles, okay? And that would be the box. The box and whisker plot, we'll go ahead and just draw our scale. What's the smallest number is 12. So maybe if we started at 10, that would make sense. So if we said 10, we'll go up by 5s maybe. And how large do the numbers get? 35, okay? So I'm just creating a scale. And I'm going to create my box between 19 and 30. So between 19 and 30 is my box. That's what we're doing it right now. Okay? Notice 19 is the lower end of my box because it's quartile 1. The upper end of my box should be at 30 because that's quartile 3. There's a line that goes inside of the box, and that represents the median. And our median was at what? 23. So I'm going to put that number right here, about 23. So Christian, you should be writing this on your paper at the bottom, drawing your box and whisker plot. I've already printed the notes, but I want you to write this information down. Now I've created my box, but I also have whiskers. What do the whiskers represent? The minimum and the maximum values, they go to those values. So I have a maximum value at 35, so I have a whisker that goes out to that point. And my minimum value is at 12, and so I have a whisker that goes to that value. So the box and whisker plot shows the quartiles. Okay, it shows some information. So here's a question that you should be able to answer back from algebra. What percent of the data lies in that whisker?
29.
Very good, 25%. Because quartile 1, that's 25% of the whole thing. Quartiles means you have 4 of them, right? Quarters, 25, 50, 75, 100. So that whisker's 25%. How about from the median on to the left? What percent would that be? 50%. 25 and 25, right? So that's half, middle. That makes sense. What if I said from quartile 3 and below, what percent of the data would be there? 75%. So each of those, the whisker and parts of the box represents 25%. That's where the number quartile comes from. Okay, quarter. But that's kind of a review, the box and whisker. That's something you should have done back in algebra. We don't see too much of that in algebra 2. Any questions about center? Middle, median, how to find it, using your calculator, the 1-bar stats, we're good. The only other thing I wanted to talk to you about today was standard deviation. So if you turn your page on the back, we have something else to talk about. Okay? And this is one of the 2, actually there's 3, measures of spread. So this is called a measure of spread. There are other measure of spreads. How spread out the data is. Can anyone think of another one? We're going to talk about what this means in a minute, but what's a measure of spread that you probably already know?
Standard deviation. 8 standard deviation.
I'm going to make you like it. It's not bad. What's a measure of, what's the smallest number minus the biggest number? Or the other way around, the biggest number minus the smallest number? Range. So another measure of center would be range. That doesn't really tell us a whole lot because maybe there's only one really big number, but the most of the data is small. The mean is a measure of center, so we're going to use the mean to find standard deviation, but any other measures of spread that you've heard? A z-score is something else that we're going to talk about with a specific kind of distribution called a normal distribution. We're going to do that on Wednesday. Anyone heard of IQR before? Interquartile range. Okay? IQR is another measure of center. It stands for interquartile range. And all that really means is on a box plot, what is Q3 minus Q1? That would be the IQR. Okay? So the IQR here would be 30 minus 19. And what would that be? What's 30 minus 19? 11. So that number is a measure of spread. How spread out is the data? Okay? The smaller the spread, the more clustered the data is, the more grouped it is. The higher the spread, the more spread out it is. So spread is a number. Okay? IQR is a number, 11. Range is a number. It's the highest minus the lowest. Okay? Standard deviation is also a number. Okay? It's a measure of spread. What kind of a number is it going to be? Well, what it does is it tells us how tightly they are clustered around the middle. So if I were highlighting, that's what I would highlight. That's the definition of standard deviation. Good. It's a number, it's a measure of spread that tells us how close the numbers are together. And standard deviation is specific how close they are to the mean. Remember what mean is. Mean is a measure of center. So standard deviation tells us how close the numbers are to the center. Okay? Now I'm going to skip this for just a minute. I want us to turn the page to this problem. And we're just going to, with that definition, the only thing you know is that standard deviation is how close they are to the middle or to the center. I want you to decide from least to greatest which one has the smallest standard deviation all the way to biggest. So we're going to order these. Okay, so I'm going to pause the recording for a minute, and I want you to look at these, and then we're going to have our lockdown drill here in a few minutes. So from least to greatest, I want you to order them. Ooh, from least to greatest. Okay? I'll get you started to help with that if you need this. Which one of those does it appear? There's one very particular that has, that has the smallest standard deviation. That means most of the values are close together around the middle. D as in dog has the smallest standard deviation because most of the numbers are around the center. So I'm going to draw in where I think the center is. It's right about here. Most of them are around there. As I get further away, there's fewer and fewer and fewer, right? Well, F is probably number 2. But I think that most of them, D is probably the smallest. Wouldn't you agree? Most of them are around the middle. So I agree. D is going to be the smallest. And then what would you said F probably next?
Yes.
I think you're probably right. All right, and I'm gonna pause it again, and y'all keep talking and thinking. You let me know. Talk to your group, not to me. So let's go to the other end. Which one of these graphs appears to have the greatest standard deviation? E. I think E is the greatest. C has some in the values in the middle, where E has nothing in the middle, right? So I believe that E is the last one. But hang on one second. But Patrick, I agree that C is the second to greatest. Okay? So now we have to look at B and A in terms of which one is the greatest versus the least, okay? Between those two. But before we get to those, are there any questions about why C and E are where they are? Okay, why is E the greatest? If I'm going to do the middle, there is nothing in the middle. Everything is far away from the middle. So I know that E has the highest. If I look over here in my middle, here we go. What's up? All right, so Shamar, back to your question, because you know now? Okay, because there are some values on the mean here in part C.
Oh, so it doesn't matter about how high the end.
Well, that's actually a really good point. Shh. These have taller bars, I agree, but because there are some values that are close to the middle, do you see what I'm saying? This does have a a very large standard deviation, but I would think that this one, most of it is away from it. Okay? It's a really good point that they are higher bars. All right, so let's look at A and B. Which one would have a smaller or a larger? Which one do you think let's go with larger. Which one is larger, A or B? B is larger because there are some in the middle, but there's a gap and some on the outside. Whereas this is just kind of very uniform. So this is kind of so I would agree that B would have the larger and then A would be here. Anybody have this order when they did it themselves? Good job. And we knew nothing else other than what the general standard deviation is, how far it is away from the middle. Okay? And so if you are presented with a graph on the SOL and it says, what's the standard deviation, we can look and see if it's if the graph looks like C or E, we know it's very large. If the graph looks like D, what kind of standard deviation is it going to have? Very small. Okay, good. If you look back up, what number for standard deviation that we're going to use, and you want to highlight this number, is this OX. It looks like an O, but it's a capital sigma. Has an O with a little tail at the top right. If you flip back to where we were before, that is the standard deviation that we're going to use. Okay? So when we do our one-bar stats, if you look at the data set that we had before on our calculator that we did our one-bar stats for, what was the standard deviation with this set? On yours. Did you see it? If you go back to one-bar stats and scroll back up, I got 6.7 approximately. Do you see that? So this 6.685 or 6.7 is going to be the standard deviation that we use. Okay? All right. Let's go ahead then and continue looking at number 2. So this is the next number. Okay? The bottom here, number 2. The Health Nut Cereal Company is looking at upgrading some of its packing machines. These machines are responsible for pouring 18 ounces of cereal into the box. The plant manager collected data on 3 of the machines. Reported in the table is the standard deviation of the boxes filled each week. He's not going to be able to replace all of the machines. Which machine would you recommend? So we're looking at machines 1, 2, and 3. Which one of these, so here's machine 1, here's machine 2, and here's machine 3. Which one would you replace and why? Why, Raul, why would you replace machine 2? So I have a really large 0.32 standard deviation, okay? And a very large standard, and I have 2 small ones, I agree, but I have 1 large standard deviation. Okay, so you think that one. Anybody have a different reason? That one's pretty inconsistent. Would you agree, machine 2? It's not very consistent. I agree. What about machine 1 and machine 3 are consistently okay. But I agree that machine 2 has this dude, right? So because it has a lot of variability. Well, it's not an outlier because it's standard deviation, right? So it's not an actual value, but it has what we call a lot of variability. It means the spread is large, right? Which means it's not as consistent. So I think that machine 2 would be a good choice. Okay? All right, so your homework is going to be doing the rest of the standard deviation problems. We skipped number 3 for some reason. You actually see number 3 written right here if you see it. It just as a typo. But we're going to do problem number 4. You're going to have to find the mean standard deviation. We will worry about this word variance next class. Number 4 and number 5, and that's it. So only 4 and 5. And yes, a calculator would be helpful. Okay? You can't take these. But you can, I'll text it. You cannot take these calculators home. Just 4 and 5, that's all your homework is. Okay? Just 4 and 5.